Okay, this is going to be section 3.4, doing some example problems. We are going to start with a problem dealing with area. So as a reminder from your geometry, area equals length times width. We will be working through example 1 on page 219. It's got multiple parts to it, so we'll work through each of those. It's first things first, says determine the function that represents the area of the region in terms of x. So the first thing we have to do is make sure we understand the information from our problem. So it gives us a farmer wishes to enclose a rectangular region. He's got 120 feet of fencing and plans to use his barn as one side of the enclosure. So I find it helpful for problems like this to where we draw a picture. So here's his barn. He's going to be using one side of the barn as part of his enclosure. So that means he's going to be using fencing for the other three sides of the enclosure. It says let x represent the length of one of the parallel sides of fencing. Parallel fence sides means the sides that will never intersect each other, like railroad ties. So that means this side is x and this side is x. Those are the parallel sides. One of the things you need to remember about a rectangle is whatever the length of one side is, the length of the opposite side is the same amount. So that's why we can put x's on both of these. The other thing you need to make sure you remember is that the total fence available is equal to 120 feet. So for that 120 feet, we've already got two sides that are x. We have to figure out something that we can use for this side over here. And what you're going to get is if all three sides together are 120 feet and we've already used X amount of feet here and X amount of feet here, then you got to take those X amount of feet away from the total 120 that you have available, and that can be rewritten as 120 minus 2x. And if this side is 120 minus 2x, then that means this side over here is also 120 minus 2x. If you were to do perimeter, slightly different calculation, but just like the opposite side here, x and x. But because we're talking about area, we need to multiply these two things together, the length and the width. And that's just going to be these two sides here. So the area for this particular one is going to be the length. Doesn't matter which side you choose as length, I'll just make x. And we're going to multiply that by the width. And so you're going to distribute. Area is going to be 120x minus 2x squared. If you want to write this in more of a standard quadratic form method, remember if you're going to move things around, keep the signs that are in front of the numbers with it. So we could also write this as negative 2x squared plus 120x as being our quadratic function that will represent the area in terms of x. Because remember, area is length times width. We found out what our length was, we found out what our width was, we've represented those quantities, and we've done the multiplication to give us an actual use. So this would be the answer to part A. So part B, talking about the restrictions on X. Well, in this context, we obviously know X cannot be a negative number because you cannot have negative length. We also know that X cannot equal 0 because you have to have some amount of fencing here to come away from the barn before you'll have an actual enclosure. And so we know X has to be greater than 0. We also know that this side over here has to be greater than 0 because you cannot have this side of the fence and this side of the fence come so close together where they're sitting on top of each other. So you have to have this side also greater than 0. And we can do some math for this one. So let's do that so we can see if this X right here has any additional restriction. Sorry about if I turn this. So we're going to subtract 120 from both sides. That's negative 2x is greater than negative 120. We're going to divide by negative 2, which leaves us with x. Now remember, when you divide by a negative number on both sides of a inequality sign, that inequality sign has to flip. Negative divided by negative is positive. 120 divided by 2 is 60. So we now have two restrictions on x. X has to be greater than 0 and x has to be less than 60. And there is no equal to's in any of that. It cannot equal 0 and it cannot equal 60. Because if we let it equal 60, when we plug it in to our width, 2 times 60 would be 120. 120 minus 120 is 0. And we've already said that this side of the fence has to be something greater than 0. So it cannot equal 60 either. And it cannot equal 0 because of this side right here cannot be a 0 length fence. So the restrictions on x you would write as 0 has to be less than x and has to be less than 60. So the sides of this fence right here are restricted to being some number between 0 and 60 without equaling either one of them. If we were to write that in interval notation, we would write it as such. X has to be on the interval between 0 and 60 with parentheses, because it can't be equal, so you would not use the square brackets. And so this would be the type of answer you'd look at for part B. Either one of these would be an acceptable solution for part B. You will not have to worry about part C because we are not going to be doing the graphing calculator portion of it. So when we do part D, if the cursor is at this location on the graph, okay, remember the same way we interpreted this on the height of a projectile, you need to remember that the x value here is your input. In this particular case, it's telling you that one side of your fence is at 18 feet. So you've got 18 feet here, 18 feet here, and then 120 minus 2 times 18, so it would be 120 minus 36, which would be 84. So you could do the math and find out that this side over here is 84. But remember also that the other value that's in this set of coordinates, when you graph it, that this is your output. And your output in this particular context, the output is your area. So if you make the short side here of your fence 18 feet, then what you're going to get is an area of your enclosure inside this fenced in area of 1,512 feet. So when you interpret those two pieces of information, you should interpret them as such. The input being the short side of your fence in feet, the output being the area of your enclosure, and you would write some sentence to that effect, describing what those two pieces of information represent. And then for part E, when it asks for the maximum area, remember all of your maximums are going to always be found at the vertex for your quadratic function, and to find the appropriate x for your vertex, remember, is negative b divided by 2a. That's your x value, and then you would use that x value to plug into this to be able to get the maximum output for your vertex area. So we have a b, 120, we have an a of negative 2, and that will lead you to the input of your vertex, which would be your maximum point here of being 30 feet. But remember, they didn't ask for what x was, they want to know what the maximum area was, so you will have to take this 30 and plug it in to your function. And your maximum area will have an enclosure of 1,800 square feet. And this will conclude example number 1.